Hey, welcome back to Mr. P. Helps with Precal. This is Unit 1, Topic 2, Lesson 1. We are defining power functions and stating the characteristics of those functions. So first we have a warm-up which includes these functions right here, which happen to all be parent functions, which you can then connect to these graphs here. So this graph right here is cubed, so this is x cubed. And I know that because it's an odd function. 1 to the third power, 2 to the third power would be 8, which is about right there. This is a rational function, so this is 1 over x, which is then reflected. So we've got 1 over x right here, which has actually been reflected in this case, and this is 1 over x squared. This is a parabola, so that's x squared, and this is square root of x, because square root of 4 is 2, or square root of 9 is 3. And this is cubic root of x. Okay, so quick review of those parent functions. What do all these functions have in common? So they all have powers. So this is 1 over x to the first, x to the third, 1 over x squared. So this is x to the 1/2 power. This is x to the 1/3 power. These functions are called power functions. So they're called power functions. We have a k, which stands for the constant, and we have a, which ends up being the exponent. So what about 2 to the power of x? So that's when x is an exponent, and those are called exponential functions. So not to be confused with these. These are x to a power of, or the reciprocal of, which we'll see here in this next slide. So there are some inverses in here. So you could say that this x squared is the inverse of square root of x. You could say that cubic root of x is the inverse of x cubed. We could also see some examples in here of things that are reciprocals. So that would be, so when you flip it, so we have like x squared and 1 over x squared are reciprocals, because this is really over 1, and if you flip it, you got the exact same thing. And then you've got, let's see, 1 over x and x would have been reciprocals. This is 1 over x cubed, which is not one of the choices. And so these two are reciprocals. I believe those are the only two. And then also, last but not least, can radicals be written as exponents? Well, they can. So as I explained before, this is really x to the 1/2 power. That's the exact same thing. X to the 1/2 power. Always use the exponent as the numerator, and then whatever the index of the radical is the denominator. So this is x to the 1/3 power. And that's going to become handy later on as we explore it right now, which is graphing these functions right here on the same coordinate plane. Now you can use a graphing calculator. If it's just x, it's going to be like this. So that takes that one out of the way. If it's x squared, so it's going to go from here, so 2, 4, then 3, 9, and so forth. And it's going to curve up like this. If it's x cubed, it's going to be here again, but it's going to be 2, 8, because 2 to the third power is 8. So what you're going to notice is that x cubed goes up faster than x squared. So the bigger the exponent, the faster it's going to go up. So that's one thing that I noticed. They are both similar. They are both increasing in this case. And the difference here is that these are both above this y equals x line, whereas the other two fraction ones are going to be below. So this is square root of x. 4 square root would be there. So this goes like that. And do notice that they're all going through this point 1, 1 and starting obviously in 0, 0. So there's more similarities there. And this is cubic root, so 8 would be 2. So it's going to be like this. All right, so once again, what you notice here is that the smaller the fraction, the lower it is, or the closer to the x-axis it's going to get. So those are some differences there. Now, these graphs are actually the exact same graphs that I just graphed a second ago, and then you have these examples. Now, using what I just talked about, so the larger the exponent, the greater the slope. So if the exponent is less than 1, then you know it's going to be below this y equals x line. And if the exponent is greater than 1, then you know it's going to go above the y equals x line. It's going to curve up above it. So this is above it, and this is below it. So we've got 2 halves. So therefore, I know that any number that's greater than 1 is going to be above it, and any number lower than 1 is going to be below it. So that means that this is going to be below it. So we have 2 fractions here. We have these 2 here, and these 2 are both improper fractions, which means they're greater than 1. So I'm going to pick and choose which one I think is the best choice, because these graphs aren't actually these they aren't actually these functions, but the whole point of this is to get you an idea of like how to make the best guess. So for instance, 1/3 is 0.3 repeated, and 2/5 is actually 0.4. It's hiding me for a second. Okay. Now 0.3 is below 0.4, so this is going to be x to the 1/3, and this would be x to the 2/5. Now, same thing with going with these. So the bigger it is, the faster it's going to go up. So 9/4 is actually 2.25, and 11/3 is actually 3.6 repeated. Now that's bigger than this, so then this has got to be x to the 9/4, and this is going to be x to the 11/3. Assuming these are the only 4 choices. But like I said, these are actually the same 4 graphs that would go with these 4 choices right here. Okay, so moving on. So now what if it is negative exponents? So instead of them curving up, they're going to curve down. So that's the big difference here between these graphs and the last graphs. So we have the bigger the number in this case, the closer it's going to be. The smaller the fraction, the closer it's going to be to the y-axis, and the bigger the number, the closer it's going to get to the x-axis. So -3 is going to curve something like this. -2 is going to curve a little bit like this. 1/2 and 1/3, so 1/2 is a little bit bigger, so it's going to curve closer, further up, and -1/3 is going to be the closest. Now, that's just me rough sketching it. Now, actually, I'm going to show you what it's going to look like. It's going to look like this is a much better map of what I just did a second ago. Now, keep in mind that the purple one is just y equals -x. So that's like -1. So if it's these numbers right here, which have absolute values that are greater than 1, then you know it's going to be closer to the y-axis. I'm sorry, no, closer to the x-axis. I said that wrong a second ago. And then the fraction is going to be closer. So the smaller the absolute value of the negative exponent is less than 1, then the closer it's going to be to the y-axis. And then the same thing for the greater the absolute value is, then the closer it's going to be to the x-axis. Okay, so using that knowledge, I'm going to now match these up. So first thing I'm going to notice is that some of these are fractions and some of these, they're all fractions. Some of them are less than 1 and some of them are greater than 1. So this one's less than 1, this one's less than 1, so is this one. This one's greater than 1, this one's greater than 1, and what that tells me, the fact that it's greater than 1, which means it's going to be above the y equals x line. So the first thing I'm going to do for all of these is plot the y equals x line. So I'm going to use 2, 2 to help me, and I could be using a dotted line. I really probably should be using a dotted line. 2, 2 is right there. And 2, 2 is right there. Okay, so now this one is just barely above the dotted line. And this one is below, this one is below, this one is above, this one is, so it's curving, it's going to end up being below. So there's only 2 that are going to end up above the dotted line. That's these 2 right here. And those happen to be these 2 over here. So 5/3. 5/4 is like 1.25. That's barely more than y equals 1x. So that's this one right here. And this one has to be this one right here. because once again, it's going to be above because it's greater than 1, and 5/3 is actually 1.6 repeated, which is the reason why it's going to slope up a little bit more than this one is. All right, so that gets rid of these two, so that leaves us 3 more choices left to go. So now the smaller the number, the lower it's going to go. So this one clearly looks like it's the smallest. This is 0.6, this is 0.75, and this is 0.6 as, no, I'm sorry. This is 0.6 repeated. This is 0.6 exactly. So this one is the least. So I'm going to go with that one being here, and that one being, so where's the other one? It's this one and this one. So 0.6 repeated. It looks like this one's a little bit closer to the line, making it larger. And this one goes right here is the best choices that I'm going to put it. Okay, so that covers both positive and negative exponent powers. Please give it a like to help you learn something about the following, and look out for the second video, which will be an explanation of how to know what it's going to look like just based upon just given the fraction. Thanks again for watching. Have a good day.